to solve this logarithmic equation, 1 plus 2 log x to base 5 is equals to log 16x minus 3 to base 5. So when you want to solve a logarithmic equation, as we've said, you must ensure that you have the same base. That is the first step, isn't it? You must have the same base. So you can see this is base 5, this is base 5, meaning this logarithm must have base 5, and it is not there, isn't it? So here we have 1, we introduce log 5 to base 5, because log 5 to base 5 is 1, a log of a number to the same base is 1. So you introduce, then we have plus 2 log x to base 5 is equals to log 16x minus 3 to base 5. Are you seeing that? Are we together? So you now have the same base all through. After ensuring you have the same base all through, you now get rid of the coefficients, isn't it? So 1 becomes the power, 5 raised to power 1 is just 5, isn't it? Meaning this one is just silent, isn't it? So here you now have log 5 to base 5 plus 2 becomes the power, isn't it? Plus log x squared to base 5, isn't it? Good. To be equals to log 16x minus 3 to base 5, isn't it? So what you do, the right hand side of the equation is already one term, isn't it? So you join the left hand side of the equation to be one term. It must be a single term is when you are able to get rid of the log on either side of the equation, isn't it? Good. So here, if we remove the log to base 5 outside, what do we get? The addition changes to multiplication, isn't it? So we now have 5 times x squared. If we factorize out log to base 5, we get 5x squared. So that when you take the log inside, multiplication goes back to addition, isn't it? Then on the right hand side of the equation, we have log 16x minus 3 to base 5. So at this level, we can now ignore log to base 5 on either side of the equation, isn't it? We can now ignore log to base 5 on either side of the equation. So if you ignore log to base 5 on either side of the equation, you remain with 5x squared to be equals to 16x minus 3. So you can see this is quadratic, isn't it? So in quadratic, this is going to be 5x squared positive 16 coming this side is minus 16x. Negative 3 coming in is plus is equals to. So at that point, you now look for the appropriate methodology, isn't it? Whether factorization is working or quadratic formula, isn't it? The formula method or factorization method, isn't it? A product of 15 and a sum of negative 16. That is negative 15 and negative 1, isn't it? See, for you to get a product of 5 times 15, and for you to get a sum of negative 16, see, that is negative 15 and negative 1, isn't it? So it means factorization works. Where factorization works, you use factorization. When factorization does not work, you use quadratic formula, isn't it? So if you factorize that, you get 5x squared minus 15x minus x plus 3 is equals to 0, isn't it? So at this level, we now have 5x is a common factor here, you remain with x minus 3. Then here negative 1 is a common factor there, you remain with x minus 3 to be equals to, because negative into negative goes back to positive, isn't it? Are we together? We are together? Good. So there we now have 5x minus 1 into x minus 3 is equals to 0. So here we have 5x minus 1 is equals to 0, or x minus 3 to be equals to 0, isn't it? So if you solve this, you get x is equals to, x is either is equals to 1 over 5 or 3. If both of them are positive, then both of them are the right values, because this log was not in absolute value. So it means x, the value of x must be positive, isn't it? Are we together? Yeah, if you solve this, 1 goes to the other side, 5x is equals to 1, meaning x is 1 over 5. Yeah, x is equals to 3. Are we together?